Let's try this again. Sorry for a small delay, I had technical problems. Let's tweet that the... How do I write delay? Oh yeah, that's delay. Right now. Sharp. Fable. Ionide. Okay, just let me check if that works. Fable. Ionide. Yeah, I believe so. This is public. Everything should be fine. So, before we, well, first of all, there are things in the life that are awkward only for the first time, and then there are fine. Unfortunately, streaming is not one of them. Definitely not one of them. Okay. First of all, before we move forward, last time, quick summary what happened last time and what's the status of the stuff I've done last time. So basically, last time I've tried to create the integration with profiler, .trace CLI profiler, and everything was fairly successful. I mean, we've created the module that was responsible for choosing project to profile and then to executing it, build it, and then profile it, and to run another utility that was responsible for creating a report out of the profiler data, and everything was fine. There is one small problem with all this stuff. It works only on Windows, unfortunately. So I've decided to put it on hold at the moment because I'm not really a big fan of adding to Ionide feature that will work only on Windows, because that's basically against the aim of my project. So yeah, that's what happened last time. That's not really super. I'm not really super happy about that, but well, that's life. From the technical point of view, last time I've shown how to integrate Ionide with the third-party command line tool, which is really useful, as shown in examples of fake packet and forge, for example, which are all really similar integrations that basically calls third-party command line tool and integrates through standard input-output communication with them. Today I will talk about something a bit different. So there is this one feature request on the Ionide repository about generating standard documentation. For FSAC functions, for example, or members and so on. And in principle, I like the idea to generate some comments, but I really hate this XML syntax, which is standard syntax used by Visual Studio and by general .NET tools. Anyway, I don't like it. Don't care that Visual Studio supports it. Yeah, that's Visual Studio's problem. What I really like is this idea shown on years ago on FSAC formatting repository to create some standard markdown documentation using conventions that later, for example, by FSAC formatting could be transformed into into XML, but that's not really my problem at the moment. I really like this format, and like there's a bit of discussion around it, and there is like really nice post message about how it should look like and how it should behave. But that's probably next step. First step is just generating this something like that as the helper by command in Visual Studio Code. This can be solved by this can be solved two ways. One is fairly simple, and it's just about creating one is fairly simple, and it just requires creating a snippet which will always insert same thing, which I don't really like this idea. The second one is more interesting, and it's really interesting from technical point of view. So basically we know we should use the F# compiler to generate right list of parameters, for example, or generate information about output type. Because we know this symbol, we for example can hover on it and get tooltip. So F# compiler service, F# compiler knows about this symbol. So we want to use this information to generate this nicely formatted comment that obviously later will need to be filled by the developer, but still it will be nicer if he will, for example, has list of parameters with names and types already there. So yeah, before we move forward to the implementation, I want to talk a bit about how the Ionide works. Because like previously I've shown integration with third-party tool, command line, and that was not really like language aware. It was not using information from compiler or anything like that, and many features are using those informations. So for example, like if we have tooltips or we have autocomplete or code lenses, it all basically is based on the compiler informations. So the architecture is fairly simple. There exists a project called F# compiler service, which is basically fork of F# compiler with a couple of additional features, couple of APIs made public that enables creating nice tooling in editors, analyzers, and so on. For example, FSAC is using it. For example, Visual Studio for Mac or Rider are using FSAC compiler services to create their own FSAC language support. This is great. Unfortunately, in Visual Studio Code and in any other alternative editor, we cannot really use it so easily. Well, the reason is pretty obvious. Visual Studio Code or Atom or Vim or Emacs are not .NET applications, so we cannot just add reference to .NET library and call APIs normally. We need to create some interface that will enable communication between editor and the .NET codebase. Basically, this is the aim of the project called FS Autocomplete, which is F# compiler service API exposed via console application, and HTTP server, which is not here, but yeah, there are two ways of communicating with that. So we have F# compiler service on bottom, then on top of it we have fsautocomplete.core, which provides several higher level functionalities, and then we have two interfaces. One is console command line console application using like standard input-output to communicate. That's used by Emacs and Vim. And the other one is SWAV version, which is using HTTP to communicate between editor and .NET codebase, and that's HTTP version is used by Atom, Visual Studio Code, because that's like, since Atom and Visual Studio Code are in JavaScript, HTTP is really natural way of communicating in JavaScript, and that was more natural than using standard input-output. And then on top of FS autocomplete the SWAV, we have Ionide, which basically whenever needed calls the FS autocomplete for information and so on. That's basically the whole architecture of the Ionide project. Yay. Okay, so fsautocomplete.core is this project in FS Autocomplete that provides several higher level abstractions over F# compiler services, which can be easily used by all editors and different communication protocols. And that's the place when we will start adding our functionality, because our functionality will be basically saying I'm here on the symbol in the line 10 column 4, and please tell me all information about parameters and about output type for this symbol. This sounds fairly simple, it actually is, but right now there is no such functionality in FS Autocomplete. We will add it, then we will add communication layer, tests, and then I will write Ionide part, which is most boring one, but yeah. So let's start here. Try get signature data. And basically really a lot of the code is similar, because that's like some boilerplate, and we will be also using symbol use for this to get this particular info. So basically what we do is we have function, it takes position, which is like line and column, it takes line string, which is basically string representing current line, it does some parsing, then it tries to find symbol at the given location, and it returns symbol use. Now out of the symbol use we will get symbol, and yeah, that sounds a bit weird, but symbol use represents usage of symbol in particular context inside of the code. Symbol is something more general. So for example, if you have function ABC that's used 3 times in your code base, then there will be one symbol used per each usage, and symbol will all be, for all those users, will be the same. Now we want to match. Symbol is a class. It has several subclasses representing different types of symbols that can exist in F#. Today we are interested in the symbol called F# member or function or value. And we will provide documentation or this signature data only for this type of symbol. In the future probably we'll add more, but as you probably noticed either during previous stream or due to my activity on GitHub, I believe into like those fast incremental updates, providing small updates and providing new features quickly to the users so they can start using it and like give feedback about it, and then if the function is popular we will move forward with adding additional cases, such as generating documentation those comments for classes or records or discriminated unions, active patterns, and so on. So let's start with any other case. Basically, every function in the in this layer of compiler service interface is really similar. It takes some input data. Many of those takes those position data, and then it returns asynchronously results, which is either failure or success. If it's failure, it just returns error message as a string, not a member function or value. And now the interesting part is going here. So first of all, we want to take params out of the symbol. So symbol has property called carried parameter groups, which is ilist. Where is it? Which is ilist of f# parameter. So basically, yeah, those are groups of the parameters that respect carrying. That's fairly simple to understand. Secmap. And out of this parameter, we don't want to return the stuff with the object with all this stuff. We want display name and we want the type. And type needs to be formatted using display context. Display context is information about, basically the most important part is what are the open namespaces or modules in given place. So for example, instead of printing out system.io.file, if the system.io is open, it will print only file, which is really nice because like you don't need all those fully qualified names. Instead, you can just get the name which is as qualified as you would use it in the code. And display context is the property of symbol use, because symbol use is the object that's connected with particular usage in particular context in particular place in the code. So symbol use display context. And just just to make it a bit nicer, we want to map it to list, and then we'll map this to list also. And the second thing we want to return is type of the output parameter from this member or function. Which is probably symbol return parameter, and return parameter is again f# parameter, which is basically the same type as p here. So we want type format, and we want again to use display context for this particular symbol use to format the type name nicely. And then we return type and params, and that's return because that's asynchronous function, and that's success because that's success. That's what we wanted. Yay. So that's fairly simple. I mean, there's a bit of boilerplate code that you need to understand, but well, it's used basically in every function, so I've just copied it. And then this part of code we've added is fairly simple, it requires some knowledge of F# compiler service, so yeah, I had to know that symbol is class and it has those subclasses that I can match on. But yeah, that's just something that I've knew. And yeah, so that's the first layer. The second layer is the place when we serialize the response into some nice JSON. Well, actually we transform the result from compiler services into nice F# type, which is easily serializable to JSON. That's a better way of putting it, I guess. Okay, so we have one type called parameter, which contains name, which is string, and type, which is string, and then we have second type, signature data, which contains output type, which is string, and parameters, which is parameter list. Yeah, that would be it. And now we just want to create a serializer function. Nature data. Yeah, that's a bit complex signature, but we will do the composition here in the function signature. So type is string and params are string list, which I believe is what we return from here. Yes, string list. We want to map tuple of string into our type that we've created, and returned data from this signature function is not parameters equals params, and the output type equals type. Not params but PMS, this mapped version, and the kind will be signature data. So that's fairly simple. That's nothing special. We basically, this is the same type that's returned from compiler service interface, and we just map it to nice format. That's not important. Comments. As you can see, that's the top level interface for the fsautocomplete.core project. It's basically like functions that are basically called by the SWAV or console version, and they just take some input data and they return already serialized response that can be served to the users, and it's the same for both versions. And yeah, that's nice. Symbol use, so yeah, we want to add it somewhere here. to try get signature data and serialize it as signature data. And as you can see, like everything, there are no errors, everything is fine. Yeah, so that's basically the first step. We can now commit the changes. I have some unsaved changes. Okay, just to make sure what we've changed. So here we've added one. Here we've added one, two types and one function, which seems fine. In the commands layer, we've just added one function, which is that executes the compiler service interface, and then takes results and serialize it. That's fine. And in interface, we've created this one function which looks for the symbol usage at this particular place where the cursor is, and then takes the symbol out of this usage, checks if it's member or function or value. If it is member or function or value, it takes the list of parameters, and it takes return parameter, and it puts it returns all the data. So yeah, so that's fairly simple. We can commit it now. Get structured. The second part is actually using this new command in both interfaces. So in case of Suave, it's super simple because that basically let's get symbol use, signature data, and here we want to call command signature data, and that's all we've needed. In the case of command line application, it's a bit more complex. Command line application, well, due to the fact that it needs to do some parsing and stuff, is a bit more complicated. Structure, signature data. So basically we add signature data as one of possible types of the command that requires position information, and then we've add additional parser combinator for this signature data, and let it be sig data. And that's it. I think I'm missing something. Oh yeah, and here, after everything is parsed, signature data, commands, signature data, yeah, and we pass usual parameters as always. So yeah, so that's basically what was necessary to add the functionality we've created in FS Autocomplete core to those interface applications. As you can see, it's fairly simple. Those those interface applications don't have any logic behind them. They just do well. In case of command line, they do parsing of the inputs. In case of the swath, it creates new. We need to create new endpoint that swath can understand. Endpoints. Okay, and now we can push the branch to the GitHub. Well, to be fair, like last part I should have done is to create testing, but since first of all I could create tests, but then running them is fairly long operation, and it would probably be even longer given the fact that I'm streaming, so the performance of my PC is not super good. So yeah, I will ignore this for a moment. Yeah, but I assume everything is working fine. That's always best assumption to do. We are doing F# and everything is compiling. Oh, we can just check if everything is compiling, I guess. We do local release. Well, yeah, that takes a moment. Yeah, as I've experienced last time, my laptop, when the streaming is turned on, is going crazy. Oh, it failed. That's interesting. Qualify symbol. Yeah, there is some interesting that the Ionide. That's interesting. Let's try it again. Uh, I'm really surprised that the Ionide was not telling me that's an error, and only when we start MS build it returned an error. That's really interesting. That may be difference between the version of, well, because like I'm compiling against F# 4.0 and Ionide is using F# compiler services that were with some changes that were done for the F# 4.1. Oh yeah, so that's passing fine. Fix small bug. And let's push it to GitHub again. That's great. What next? Now we go to not to FS autocomplete. We are in FS autocomplete. Now we go to Ionide. Uh, whoops. Fuck me. Mm, okay. Ionide. What we want to do? First of all, we want to tell packet to use not cache but signal. What was the name of the branch? Not here. Structured signature. And let's that actually won't work. I need to close Visual Studio for a moment. Close Visual Studio Code for a moment. Open. For some reason, upgrading the version of Git dependency is not working well on this machine. It works fine on my other machine, but so it's probably something to do with configuration of Git. And let's now run a packet update. This will probably take a moment, but yeah. Well, yeah, that takes a moment because now after it got cloned, uh, it's running the local release process on FS autocomplete, which, yeah, given the fact that I'm streaming, it will take a moment. Anything interesting happening on Twitter? No, not really. Someone retweeted me. That's nice. Yeah, it's still running, unfortunately. Uh, it's much faster than it's much faster when I'm not streaming. Like I'm not really sure what should be the right settings for the streaming, and I'm not really I don't care too much because I'm getting soon back home and then I will have different machine and I will try streaming from this different machine. That should be much better. Okay, so we've updated. Oh, there's one more thing. After we've updated dependency, I need to run a build process on Ionide extension, which basically will build Ionide and will copy downloaded FS autocomplete into right place. That's not really always necessary. I just have really weird process, as I've mentioned last time. I'm just dog fooding the Ionide all time, so instead of using like experimental instances in Visual Studio Code as suggested, I'm just always using the development version of Ionide, using some symlinking magic and stuff like that, so it makes process a bit more complex, but at least I need to fix whatever whatever book I've created in latest version, because I wouldn't be able to work. So that's something that's pushing me forward. Yeah, this takes a moment again. Mm. Anyway, I won't dive deep today into the Visual Studio Code extensions in general. If you would be interested to hear more about it, there on the Fable conf I will be doing FableConf. FableConf that's happening in September in Bordeaux, France, 22nd, 23rd September, France. I will be doing both talk about building editor tooling with Fable and also the workshop. 1 hour 50 minutes. I really hope that it will be longer. I will be doing workshop about writing Visual Studio Code extension with Fable. So I really encourage you to buy tickets and come to Bordeaux. It will be great fun, great food, great wine, great people, and some decent stuff at the conference, I would say so. Yay, so how it goes. Packet file. That's not important. Anyway, that's not important. I think that copying FS autocomplete was successful, which is what I care about right now. Let me check that. No, it was not successful. Oh god, I'm fucked. Why? What's wrong? Okay, I'm confused. I'm really not super happy right now. Oh, it's there. Interesting. Oh, because I think I have some... yeah, I have filtering. Oh, that was stupid. I think I have global filtering so that bin and obayot folders are not displayed in the tree explorer, which got me confused. Okay. So now what we want to do, first of all we want to create basically the same types that we had on FS autocomplete site. Fuck, this is way too slow. Core command response. So those two types. And then signature data result Okay, so we have type, and the other thing we need to do for just sake of communication is creating request helpers. And I hope I remember it right. We can check it here. FS autocomplete swath. Signature data. Yeah, that's fine. We pass everything, and that's fine. Okay, okay. What we do next? Basically, the next step is why this is 6. Did I have changed something in README? Anyway. Okay, and signature data endpoint. Now we want to add a new component. Signature data fs. We want to add it to also here. Where I will put it, it's actually pretty intro. Rename works somewhere here. Yeah, what next? That's a great question. We will copy some code as always. Let's copy some code from the tooltips. How should activate function work? Selector? No, not really. Just disposables. What next? Yeah, this is this moment which I don't know what to do next. This is this moment which is not really the nice, which is not really nice part of the working on something. Oh, I know what can help. Basically send line command, for example. Okay, editor selection is empty. Send line range. Okay, let's try this. We want to create function. Basically, all what we want to do right now is create command that can be executed. Generate doc, which takes nothing and basically returns nothing. We want to get active editor. This window, active text editor, document, match editor with F#. That's not a document F#. So basically we only act if it's F# document. If it's not, we do nothing. What next? Editor. Not editor. Selection. That should be editors. Oh, that may be text editor. I'm pretty sure that I've used really similar code somewhere, but I don't really remember where. Anyway, selection. Active line +1. Active character +1. Okay. What next? Language service. Signature data. Signature data. And what we want to get. File name. Editor. File name. Line. Call. Those should be int. Those two are floats just because basically JavaScript runtime there is no difference between integers and floats and so on. So just for the sake of safety and choosing right default, anything that's number in TypeScript definition false is transformed to the float in F# by the Fable. That's the safest way. And you can, like, without any problem, just cast those two things. Okay, and promise on success iter. Do I have iter? No, I don't. On success. Okay. And now we want to register the function as a function. that sounded stupid. We want to register our function as a command in Visual Studio Code. F# narrate dog. We want to add it as one of the commands in plugin manifest. And we want to enable the module in our activation function that's called whenever the plugin is starting. And now let's try to build it. Whoops, that won't build. Disposables. Again, the whole process is not super fast, but that's only because well, because of streaming. Usually it's much faster. And I hope everything will work. Compiling. Oh, it's been over 1 hour today. That's interesting. Okay, it's starting to move forward. Okay, status build okay. Reload window. As I've mentioned, I'm using this like Symlinks developer version of Ionide as my main version of Ionide. So whenever I do any changes, I can reload window, and I have them in my normal instance, which is probably not super smart, but works for me and my workflow. Yeah, let's wait a moment until it loads everything, and at the same time let's fire developer console. Let's maximize it. Clear. Okay, everything is, let's put cursor somewhere here. Let's clear. Uh, and let's try to find, yeah, there is generate doc function, which that's probably not really visible on the stream, but there is request to signature data endpoint. There is response from signature data endpoint, which took 99 milliseconds. And it basically returns what we wanted. So we know that the output type of the function we were at is unit, which we agree with, and then we know that parameters is array of 1, and the first carried group is also has one element. This one element has name disposables and has type disposable array, which is totally, yeah, it's perfect. Uh, Maybe let's try to find something more interesting. Do we have some more interesting function here? Quest. Some higher level function. Do I have something? Oh, that one actually is interesting. Yeah, let's try this one. It takes two strings and it returns something fancy like tuple of console and output channel logger and the function, whatever this means. Oh, I haven't done it. So generate doc, and let's go to output. The output type is console and output channel logger star string arrow unit, which is exactly what we have. And parameters are there are two arrays on top, so there are two carried groups, which is, yeah, we totally agree with that. And then first carried group is what has one element, which is name source type string. The second element is name channel name type string, which is exactly what we wanted. Uh, which is great, which is basically great. So we are at this point, we get result and we have all data that's necessary. This is signature data result. So we have some additional typing over here. And now, what now? That's a great question. Now we want to format string of our string that represents our command, which is basically something like printf. Okay, other way around. I would like to check actually what will happen. Do I have such function? Function that takes a tuple as an input parameter. Oh, for example, this one, which takes tuple as a first parameter, which takes tuple as a second parameter, which returns object. Let's try this. Generate doc. Let's clear that, and let's try generate doc again. Okay, so actually it looks like, I'm not really sure why, but it looks like the input array always has one element. That's interesting, to be fair. And like, if, like for example, it's tuple, it knows that it's tuple. Maybe this one. I need to generate doc. Oh, and now those are two parameters because, oh, I know, because right here this is one named parameter which is tupled, and here those are two separate parameters that are named separately, which totally makes sense. I would say so, at least. And probably if that here would be another create group which would have also named members, named fields of the tuple, then it would be, yeah, that totally makes sense. Okay, so first of all we want to basically flatten the parameter list. P data parameters sec collect it. Because to be fair, we just want to display them in one on one level. We don't want to do some groups. At least initially, we might discuss about it later in some issue. And we want to map it to string. Map fun parameter as printf. This is like two spaces, and then there will be name. Let's make this star. para type matter of type and we will add type which is prm name prm type and we want to do string concat so we have list of parameters. Now we want to create some kind of body. Oh yeah, we probably will be best if we will use the triple quotes because there are a lot of escaping here. Will it be the best? Maybe not really because we want to add new lines. So we want escaping. Oh, this will be annoying. Title of name of the function /n parameters /n /n oh, and here in front of every line I need to add also comment output type /n. If anyone knows better way to do this, please let me know because I'm going crazy already. Okay, so let's say that's my command. And now just for sake of testing, let's print it out. And I think if this will be working fine, I will end for today. Because like it's almost 1 hour, 30 minutes. This is a bit tiring to be fair. Especially after a full day of work and doing other stuff. Yeah. Oh, new comment in my favorite book. By the way, I've promised that. So I've promised that to Microsoft. So I need to do the stuff. There is this amazing issue in NuGet Gallery, basically, which adds 2 lines of code, uh, which would make Packet visible as one of the choices for to manage NuGet packages in new NuGet Gallery page. The issue has been is 12 days old. The only comment from it's the most upvoted issue in NuGet Gallery repository. It's, I believe, most commented, or maybe second most commented issue in the NuGet Gallery history. There was one comment from the member of NuGet team, and he basically said no because no. Please notice that the changes were approved earlier by another member of NuGet team. Comment was not really well taken by the community. And that's 11 days later, almost 300 upvotes. We still have no response from the NuGet team or .NET Foundation, which is apparently owner of NuGet Gallery, or no one. People are going crazy, and that's how this one comment. Oh, and after this one comment, there was a couple of days when people asked questions, and then it was just closed without an explanation. So that's also not really super good way of managing open source product, at least in my opinion. So yeah, so we are here 12 days later, still no responses, and we're waiting for Microsoft. That's how Microsoft loves open source nowadays. Okay. So please, if any one of you that is watching this video, either live or later on YouTube, please go here, write comment. Not only if you are using Packet, but also if you care about open source and community, and believe that community is way forward for .NET ecosystem, and that not invented here syndrome from Microsoft is hurting everyone. Please comment, please upvote, yeah, and have fun. Okay. Okay, this is almost fine, I believe. I believe there's one off by one error somewhere. Oh, because like those should start. But anyway, this is basically what I wanted from the feature. So now the last step is basically putting this output into editor, which is fairly simple, and I'm going to be going today through it, because that's basically like usage of Visual Studio Code API, which is really well documented, and that's nothing super fancy. So yeah, it was fun. I will probably finish the feature today and release it today, so you should be able to play with it tomorrow and see how it works. And really, thanks again for watching, and see you again next time.